Hello friends, welcome back to my channel. So today we are gonna do chemistry. Yes, chemistry we are gonna do where we will be studying some laws of conservation of mass, constant proportions, and Dalton's atomic theory. So let's begin. We have law of conservation of mass. So law of conservation of mass says that mass can neither be created nor be destroyed. That is, the mass of the constituents that are performing a chemical reaction, that is the reactants before the chemical reaction and after the chemical reaction when the product is formed, they both are equal. In a better way we can say that mass of reactant A plus B is equal to the mass of product AB. So this is what is known as law of conservation of mass, and this is a universal law. Now we will be moving next to the law of constant proportions, which says that in a compound elements are present in definite proportions. We can say that it is very obvious thing. Lavoisier was the one who discovered this law, and we can say here that let's take an example of a compound that is water, which has its constant elements. We all know hydrogen and what oxygen. So hydrogen and oxygen have a ratio by mass 1:8. So whatever the mass of hydrogen would be and the mass of oxygen in that mass of water, it will always be in the same ratio. For example, hydrogen has a mass of 3 grams and we have the ratio as 1:8. So the mass of oxygen would be 24 grams because when we take out the ratio, it would be 1:8. So this is what the law of constant proportion says. Now, let's move to John Dalton. Who is he? John Dalton was born in a poor weaver's family in 1766 in England. He began his career as a teacher at the age of 12 years. 7 years later, he became a school principal, and we can say at the age of just 19. In 1793, he left for Manchester to teach mathematics, physics, and chemistry in a college. He spent most of the time there teaching and researching. In 1808, he presented his atomic theory, and this atomic theory was a turning point in the study of matter, which actually scientists say led to the revolution, a revolution in chemistry for the discovery of atoms, and it was started by John Dalton. So now we will be looking towards his theories, that what his theories say about the atoms. So every matter is made up of very small particles, which are known as atoms. So each matter has atoms. Next, atoms are the ultimate particle and cannot be further divided into smaller particles. We can clearly understand that he's saying that atoms are smallish and they cannot be divided furthermore. Atoms can neither be created nor be destroyed during a physical change or a chemical reaction. All atoms of a particular elements are identical. He's saying that neither you can destroy atoms nor you can create atoms. They are always the same, always in the same compound, right? Now we have next that they have same mass, size, and chemical properties. That is, they are identical. Atoms of different elements have different masses, size, and also different chemical properties. So we can say that they are of different elements, there are different atoms. Atoms in the same element are only identical, not in all other elements. Atoms are the smallest particles of matter which can take part in chemical reaction. Just he is repeating the same thing, that they are the smallest and they cannot be divided, hence they are the smallest particles taking part in a chemical reaction. Next we have atom of the same or different elements combine in small whole number ratio to form molecules of a compound. They combine in a small whole number ratio, right? Ratio by mass, that is what he's want to say, that we actually explained in the law of constant proportions. But yes, not all of these were correct. There were some drawbacks. So first drawback states that atoms can be further divided into smaller particles called electrons, protons, and neutrons, later discovered. Atoms of the same element can have masses. These are called isotopes. And atoms of different elements can have the same mass, and these are called isobars. So we are actually proving three of his theories incorrect, because these were later found out. Now, he actually gave many symbols for the different elements. So, let's have a quick look at them. How these symbols actually looked at that point of time. How he made to use symbols. That was all for today. So, thank you for watching. Don't forget to like, comment, and share. Thank you, everyone.